Gidon has made scientific contributions, along with many other contributions. He published a paper in 2019 in Scientific America, he along with some colleagues, which really lays out the issues of climate change in relation to animal food intake. So let's move right on in the presentation, Heather.
Hello, everybody. Thanks for tuning in. I was asked by John to talk about my approach to making the world a better place through better agricultural policies and dietary choices. And that's the plan for the next 20 minutes. I wanted to start by thanking John and the McDougall Foundation for the opportunity, for the invitation, and for the opportunity to speak with you. Thank you. Okay, so this is the plan. I will start with highlighting some of the key geophysical costs agriculture exacts on the environment. And then I will describe to you a set of principles that allow you together to perfect both environmentally and nutritionally your diet simultaneously, so that there are no conflicts or sort of hard choices to make. And in that, I will primarily rely on papers that I've written in the last 4 or 5 years or so. If you're gonna fall asleep after this slide, let me just leave you with the take-home message before you do, and that is as follows. For the most part, the less animal products, the better. There are some exceptions, but they are definitely the exceptions and not the rule. Most important by far, with no distant second to speak of, is eliminate beef. Beef alone, in any kind of beef. It makes no difference, really. And in some senses, it is even worse to eat grass-based beef. I also want to discourage very much the fixation that unfortunately pervades the food discussion on local. Local is mostly irrelevant and unimportant. Efficiently produced, now that's the new local. That's what one should focus on. So let's talk a little bit about some of the key geophysical effects of agriculture. These pictures are taken from recent bike ride in the fall to near my house, Hawthorne Valley Farm in the Hudson Valley. Very often people begin and sometimes unfortunately end the discussion about the environmental consequences of agriculture by emphasizing greenhouse gases. So let's look at this. Agriculture directly contributes 9% of the total US greenhouse gas emissions, and it's broken down. More than half is due to crops. That's primarily fertilizer and agrochemical production. Livestock is another 40%, and the rest is fuel. So it's primarily about producing the animal-based portion of the American diet. Most estimates add to those 9% of direct emissions from agriculture additional emissions from other sectors like electricity, like transportation, like industry, and so forth. And so upon adding those, which I show here as those purple wedges, you get something like 1/5 of the national greenhouse gas emission is due to feeding the nation. It's not small, it's important, but it is not the most important. What is the most important? Well, for one thing, agriculture dominates land use. So let's look at this. The horizontal axis here is, let me move myself, percent of total US surface area. So you see the pasture and range account together, grazed forest and so forth, to a third of the entire US surface area. Corn, hay, and other crops that are only grown to feed animals, that's another 18% or so. Total agricultural land use is just shy of 1/2 of the entire surface area of the US. So it is by far the most dominant, and it is interesting to note that all the stuff that we actually eat, vegetable, fruit, nuts, that's 0.5%. All of those are collectively just under 0.5% of the US land area, is shown right here in this vertical green line. It is very, very little. And many of us live in cities and towns. All of those put together, even with the most generous definition of what is a human dwelling, also amounts to about 0.5%. So agriculture really dominates the way we use land. And this is important because most environmental costs of diet just rise linearly as the land that they require rises as well. So if you use 1/2 of the nation's total surface area, you better know for sure that you are doing it very carefully and judiciously. And the answer today is that we are doing it in the most opposite manner to careful and judicious possible. Let's look at some examples of how it actually affects the planet, that land use, okay? Here is a property measured by satellites from space, which is called albedo, which is just the reflectivity. So the sun shines on Earth. This is what drives this energy drives the biosphere. And albedo is a measure of how much of that incoming radiation is reflected without being absorbed. And this shows you the change in the reflectivity as a result of modifying the land for whatever human purpose we modify it for. And you see the US, that you're probably most familiar with, has this dipole pattern where roughly the eastern half became that much more reflective. That's mostly, think about a cornfield in Iowa in February covered in fresh white snow. Well, it reflects a lot more than if that were left alone to return to the forest it once was, which is not quite this shiny. The reverse is true in the more arid part of the American West. Now, if you know anything about climate, you know that the climate of a particular place to a large extent depends on the planetary wave pattern around the globe. The planetary wave pattern is partly forced, in other words, prodded to be to manifest itself by distribution of uneven distribution of temperature. Such changes contribute greatly to that. So allocating the entire eastern half of the US primarily to corn, soy, and cotton and rice and things like that really alters the planetary wave pattern and climate. This is a corollary of that, how much of the downward radiation is absorbed. And you see that the eastern US has a negative, discernibly negative values, and the Western has discernibly positive values as a result of land use changes. So it's not at all fanciful to say you choose to eat in a manner that requires a lot of corn and soy or any large-scale agriculture, you change the planetary heat balance, the planetary radiative balance, and the planetary wave pattern, all of those. Biodiversity is another huge impact of agriculture. So here is an estimate from 20 years ago or so. In recent decades, 50 to 90% decline in European on-farm birds. Is another early estimate. In the 12 years that launched the 21st century, the USDA killed 1.2 million coyotes because ranchers didn't like them. That's 100,000 coyotes per year. Think about a pile of 100,000 German Shepherd carcasses piled together. That's how much we kill every year in the name of ranching. And here's one of the even less fortunate denizens of the planet, the Mexican gray wolf, which ranchers all but wiped out. Some people maintain that beef, when used, when fed grass or when is based on grazing, is some kind of a panacea for biodiversity. That, unfortunately, is not true. And let me show you an example here from PNAS, the Proceedings of the National Academy of Science, where we take the biodiversity of natural rangeland, and whatever biodiversity it is, we call it unit. That's our one, okay? So that is that natural, and it gets the value of 1. Everything else has lower biodiversity. We take the biodiversity of those lower values divided by the biodiversity of the unperturbed rangeland, and we get a ratio. What is that ratio? Moderately used rangeland has lost already 40% of its biodiversity. Intensively used lost half. Man-made grasslands, which I apologize for the term, that's the term that they use, but that means places that are now grassland that would otherwise not be grassland, they would be forest or whatever, that lost 70% of the biodiversity. The notion that range-based beef ranching is beneficial to biodiversity is sharply at odds with reality. And here is a nice summary of that by one of the titans of wildlife biodiversity, Bill Ripley of Oregon State. And the title just says it all. Biodiversity conservation, the key is reducing meat consumption. This person speaks not out of fanciful assertions, but based on careful data collection and analysis. That is the reality. It follows from that eating land cheap foods is one of the callings of our time. Land cheap meaning, here you have one person who eats a steak, let's say provides 40 grams of protein. You can have the same 40 grams of protein from lentils. It will require a minuscule fraction of the land. That's land cheap. That's what I mean by land cheap. Okay. Water pollution and coastal dead zones. Every now and again, you come to any coast of the Gulf Coast of the US, and that is what you see, massive die-offs. Why? If you dive shallow underwater, you see, instead of those beautiful azure water that characterize the Gulf of Mexico, you see this murky green with very, very reduced visibility. And the most important aspect of it is that this greenness is excess growth of algae, which, the Mississippi River is mostly heavily cultivated, mostly heavily cultivated. All the excess inefficient fertilizer applied there washes into the Gulf of Mexico. It promotes algal growth. Those algae live briefly and then die, and their rotting bodies essentially rob the water column of oxygen, dissolved oxygen. So you see right here what we call anoxia or dead zone, more poetically, which are vast regions with so little oxygen in the water that most marine life just die. So you see open ocean values of the dissolved oxygen would be 10 to 100 milligrams of oxygen per liter of seawater. Well, here we see values between 0 and 5, vastly reduced. And that is directly because of the cultivation of the Mississippi Basin. We have important impacts on hydrobiogeochemistry. The most important effects that farmers have on the land is they fertilize, they aerate the soil, they tile, not till, but tile. It's sort of a practice that hasten the removal of precipitation water from the land into the irrigation ditches and then into rivers. And they degrade soil biota by doing all of those things, and of course applying agrochemicals. That results in the soil bacteria having much less time to work on and neutralize stuff that farmers apply to the land. So you see in this graph, you see the comparison of a modified and a natural ecosystem after a rain event, which starts at day 0 right here. And you see that the natural one takes a long time to rise to a modest amount of flow, and then it very slowly and gradually dies down back to normal flow. The modified behaves completely differently. It's a huge rapid pulse and a rapid decline back to normal state. This is very reminiscent of the glycemic response to properly chosen food in blue and highly processed simple starches and sugars in green. It's the land equivalent of pre-diabetes, essentially. And this is what, again, it looks like in terms of dissolved oxygen near the bottom, very reduced and killing massive amounts of marine biota. Back and now to the other element of the plan, environmentally and nutritionally perfecting your diet. And those are basically the choices that we have here. This is a nice dish of hummus that I make. I'm from Israel, so hummus is a key element of my diet. That kind of eating is consistent with this kind of beauty. And this kind of eating on the lower right is consistent with this kind of environment. That's basically the choice. There is no third option. This is a paper we published in 2016, I think, quantifying the resources needed to produce 1 kilogram of animal protein. The first panel shows you land use, and you see beef requires 3,300 square meters of land allocated per year to produce a kilogram of protein from beef. What about eggs? Something like 30 or 50. You see here the transparent green, that's the range spanned by various plants. Now you see what land cheap eating looks like. Water, it's less of a clear cut because some things like almonds in the Central Valley or rice in Vietnam, those, require prodigious amounts of water. But still, beef requires disproportionate amount. You see all the other ones are 2-3 cubic meters per kilogram of protein. Beef is 37. And we have to always truncate the beef bar, or else it will just go to the next town to the right. Here's greenhouse gas emissions. Again, beef 200, all the rest something like 2 to 20. And nitrogen fertilizer, the cause of the oceanic dead zones, again, beef 3,900, all the rest somewhere between 300 and 500. Huge disparity. So what do we conclude here? Focus for a minute on the bottom. Beef resource needs are at least 10 times larger than those of other animal products. Other livestock categories are roughly comparable to one another, and plants are mostly, but not only, somewhat too much less resource intensive. Now, against this backdrop, look on the upper right, this very large panel, and see what Americans actually get their protein from. And you see that beef contributes 10%. Beef, the paragon of inefficiency that should be minimized, hopefully to zero, that one contributes a full 10%. Poultry is much more efficient, thankfully, and it contributes 15%. This is another paper where we're trying to follow the flow of substances into the livestock production enterprise. And, there are different inputs like corn, soybean, hay, pasture, etc. Okay, all of those contribute 36 petagrams, or millions of tons of protein from all of those sources into the beef enterprise. And what do we get as actual beef protein? 36 in, 1 out. The efficiency is shown right here, and that is 3%. 97% of all the protein that you put in, just pure loss, 97%. Now you may ask, suppose I took all of those resources and I allocated them to a sensible, sound, plant-based diet that delivers the same amount of protein. How many more Americans can I support this way? The answer is shown right here. 161 million additional Americans fed in full. That's half the nation again. The increase in protein yield that such a transition will result in will deliver 430% more protein. It's a staggering amount. Let's look at a more recent paper where we're trying to take the US meat and devise alternative plant-based diet to it. Something like that. You take all of those things that fall into this red meat category and replace them with something that like the lower right. Okay, and we strictly enforce more than 40 specific nutrients in the diet that have to at least meet the requirements, if not more. What happens if you do something like that? Well, let's start with the environmental consequences. In terms of land, for example, you replace beef alone, you see right here, you, instead of using 38%, you drop to 11%. So you basically cut your land use by 2/3. You only need 1/3. In terms of gram of reactive nitrogen, that's just fertilizer. From 44% of the total US consumption of that resource, you drop down to 10. That's less than a quarter. What about greenhouse gas emissions in panel D? Well, instead of 39, you drop to 6. Massive reduction. And in terms of water use, well, only from 18% to 13%. What about nutritional impact? This shows you the percent of delivery of specific nutrients as expressed as percent of today's mean diet. So for example, manganese, the alternative plant-based diet delivers something like 4.3 times as much manganese as the beef it replaces, or in this case, it's actually all meat replacement. I want to show you that the thing that's important is that when you are larger than 100, this is 100, when you're to the right of 100, it means you get more of that. Well, what is it? Are these things bad for you or good for you? Well, here's folate, beta carotene, vitamin K, vitamin A, soluble fiber, phytosterols, total fiber, magnesium. All of those things are known to be protective nutrients. The corollary, you take your meat, replace it with a sensible and carefully designed plant-based diet, you not only dramatically reduce your environmental impact, you also dramatically enhance your ingestion rate of protective micronutrients. So, eating determines your longevity and health span as powerfully as genetics or exercising. We all know that by now. My work shows that with the, sorry, this is a little typo there, but with the right dietary choices, you can greatly reduce your environmental and societal impacts. And this is what I mean by the latter. You get to decide who wins: a hay farmer enabling growing Chinese demand for beef, or salmon that depend on those contested waters and the native population that depend on them. That kind of dilemma would correspond to Eastern Oregon, for example, where this is exactly the dichotomy of water allocation being discussed. Or who wins? A Mississippi shrimper whose livelihood has been decimated by those dead zones, or an Iowa corn farmer whose nitrogen-rich effluent kills her catch? Is what's on your plate furthering your health or furthering the health of the major agrobusiness corporations? It's your choice. Importantly, health, environmental, and societal considerations often lead in similar directions, but proceed with caution because it is not universally true. Thank you. It was an honor to speak to you.
I want to ask you a couple of questions that I don't think anybody else could answer, but I at least want to propose to you that have been asked to me, and that is that what are we going to do if we decide to go vegan, which obviously we need to do? What are we going to do with all the farm animals? And is this going to pollute the environment? That's one question. And the other question is, again, related to that, what happens is people follow the kind of diet that I recommend, and 8 billion people lose weight. You know, half of them, 4 billion of them, are overweight. What about all the carbon that's released by this kind of change, weight loss? Have you thought about that, or this kind of implication, or am I pushing you a little hard?
No, not hard at all. So the weight loss, yeah, it's been calculated. I didn't do that. It's an incredibly modest amount. Yeah, I mean, it will contribute a little more carbon in the atmosphere. It's a trivial amount. There has been a paper about actually human exhalation. That too is rather trivial. So I mean, yeah, there's maybe 7.5 billion of us. It's not really the small addition due to excess weight is not hugely important. What will happen to animals? It's really a non-issue. In other words, we will use the inventory that currently exists the same way we have been for centuries, and not replenish it, and that's it. And there's really no issue to speak of here.
There's one other question, and I ask you because you're one of the scientists that we have today. One other question that's come up, and that is, what would happen if we solve the pollution problem? And by solving the pollution problem, we eliminate particulate matter. It's been estimated that by eliminating particulate matter, which would happen in a matter of days, that the planetary temperature would increase at least 1 degree. Have you heard about that?
Yes. Yeah. So things that are particles in the atmosphere that are rather blackish and rather large, both criteria are met by most tailpipe pollution or smokestack pollution. If they persist near the surface, if they don't go far up into the atmosphere, they have a significant radiative effect. I think that the more important, if you're going to go down the rabbit hole of particulate, which is a very worthy thing to do, you would ask, rather than the question that you asked, you would ask instead, how many lives and pulmonary disease cases are to be saved by reducing particulate? And the answer is there is actually a paper right now from the Tillman Group at the University of Minnesota to be published soon at PNAS that addresses this question. And it's unbelievable. Unbelievable. Eliminating animal agriculture would save more lives lost to particulate matter related diseases than improving the fleet average gas mileage, which I was a reviewer of this paper, not an author, and I tipped my cap to this paper, to these authors, because it is a very surprising and incredibly powerful result related to particulate.
Well, the reason I ask this question is because the argument is that we need to lower the temperature by changing our diet first, or at least along with, at the same pace that we eliminate fossil fuels. Because if we didn't lower carbon first in the atmosphere by something as simple and as important as dietary change, if we suddenly drop the particulate matter, which would happen in a matter of days to weeks at most, the temperature would rise of the planet to an unlivable temperature.
No. That's overstating the case. Your point is correct. You are overplaying your hand.
Okay.
It is true, for example, it is well known that the eastern third of the US in the last several decades has been significantly warmer than it has been in the past, only because of the Clean Air Act. Until Trump stopped progress, there was a steady progress in air quality, and that in turn, because of clearing the air and allowing more surface, more solar radiation to hit the surface, that actually resulted in warming. That is warming that societally any sensible person would say it's a small price to pay for very significant reduction in pulmonary emergency care visits.
Well, I guess the point I'm trying to make is it makes it even more paramount that we focus on dietary change and lowering the amount of carbon that's being produced. You know, as I say, it has to be done along with, if not ahead of, our efforts to get rid of the particulate matter from all of the combustion that goes on with fossil fuels. Thank you for answering those questions. Those are really tough questions that I have not had anybody answer in the past, and I appreciate your answers.